Alright. My way is harder to understand, but it's much quicker. Differentiation is longer, but safer. Right, so you can see what suits you. Okay? So, a river flows at constant speed 4 meters per second between straight parallel banks at distance 60 meters apart. A woman can row a boat with speed 1 meter per second in still water. So I'm going to draw myself a nice picture. Okay? River goes at 4, woman aims up at 1. The woman has to go downstream, no matter what, she is definitely going downstream. Okay? Now, would everybody agree that, alright, and of course they decided to use a woman, so I'd end up using W twice. So, I suppose I can just I'll call it the river instead of the water this time. Right? So, velocity of the river is 4I. Velocity of the woman in the river is what she tries to do. Pick an angle, any angle. Pick a letter. We're going for alpha. Alright? You're going for alpha. And the woman is basically saying, okay, I'm pretty doomed here. I assume I'm going to have to fight it slightly. Alright? So because she's fighting it slightly, we'll say alpha here. And then we'll go for, what's it? 1 sine alpha. And 1 cos alpha. Alright? Now, next piece of information to realise is that where does the woman actually go? We'll put this in red. What actually happens to her?
Goes downstream.
Now, she goes downstream. See the way I drew it there? That's a pretty poor performance, isn't it? As in she's getting thrown all the way downstream. If she wants to get across in the shortest path possible, what would she like in an ideal world? In an ideal world, she'd go straight across. Is that possible? No. So, technically speaking, if I was to talk about this angle X here, everybody see angle X? If I was to talk about that angle X would be, you want it to be as large as possible to make the shortest time across. But less about that, we'll get to the, we'll do the derivative way like we did in the book. Okay? And here's what I recommend. Nice. So here's what I might recommend, alright? So phi WR. So, phi WR is the velocity of the woman minus the velocity of the river, alright? So therefore, what are we going to say here? Okay, so the velocity of the woman is phi WR plus phi R. Right? Now, what is phi WR? We actually have it here, don't we? Minus 1 cos alpha I plus sine alpha j, don't we? We have that. Okay? And the next thing we do then is we're going to find the velocity of the woman. Velocity of the woman is, we add the two of them together, don't we? So, we're adding the river to this part here. Two of them are getting added together. So, what we're going to get is velocity of the woman is actually 4 minus cos. Yes?
Just the first part, the shortest time, not the...
Oh, is the shortest time, and the second part is?
The second part is what you're doing.
Alright, so I'll just do part 2 first, is that okay?
Yeah.
So lads, I'm actually doing part 2 first. I'm going for the shortest distance, and then the shortest time is just aimed directly up. So 60 seconds, is it?
Yeah.
Alright, fair enough. It's like, here's 5 marks. Knock yourself out. Alright. So, we're doing part 2. 4 minus cos alpha, you cool with that? And then plus sine alpha j. Now, remember I discussed earlier that you want that to be as large as possible. You want your angle to be a maximum, don't you? You want that to be a max. So technically speaking, you want tan x. Tan x is equal to sine alpha over 4 minus cos alpha. And you want this to be a maximum. So in differentiation, a maximum is where the derivative equals 0. Okay? So we're going to do some differentiation here. I have a much shorter way of doing this, by the way. I'll get to it in a minute. Alright? So you're going to go for u equals sine alpha. We're going for du d alpha. What happens when you differentiate sine alpha? Plus cos alpha. You're thinking about integration. They're very confusing. That's why you need to constantly check your log tables. Dv d alpha. Get rid of the 4. When you differentiate cos alpha, it turns into minus sine alpha, but the double negative will make it sine alpha. Now, no need to differentiate the other side. All you want to know is, when is tan x a maximum? The maximum value of tan x will cause it to become more and more vertical, and that's exactly what you're looking for. Okay? Find the distance travelled by the boat. Oh, lovely. Now, let's do this. We're doing the quotient rule of differentiation. We're doing phi du dx minus u dv dx all over phi squared. We're hoping you all know that off by heart at this stage. Okay? Especially with an upcoming test in all calculus. Alright? So, we're going to go with 4 minus cos alpha times du dx, which is cos alpha, minus u times dv dx, which is minus sine alpha by sine alpha. All over what? 4 minus cos alpha squared. Alright? Multiply out the top part, and what do we get? 4 cos alpha minus cos squared alpha minus sine squared alpha. No need to multiply out the bottom. I'm highly lazy, don't like doing extra work. Why do I not need to worry about the bottom part? It's going to equal 0. And because it equals 0, when it cross multiplies, it's just going to get rid of the denominator. Anyway, what's the deal with minus cos squared minus sine squared alpha? Yeah, it's minus cos squared alpha plus sine squared alpha, which is minus 1. So we're going to end up with 4 cos alpha minus 1 equals 0. Then we're going to end up with cos alpha equals 1. Cos alpha equals a quarter. And then alpha therefore must equal, what's cos inverse the quarter? $75.52. Is that okay with you guys? You good? Alrighty then. Alright. Now, everything's in vectors, isn't it? Would you agree? I could just find out sine alpha directly, could I? Because if cos alpha is a quarter, adjacent is 1, hypotenuse is 4. That means the opposite will be root 15. This means sine alpha would be root 15 over 4, and cos alpha is a quarter. Is that right? Root 15 over 4 and 1/4. Okay. So, you go back to the very top here, and it's looking for the distance travelled by the boat when it crosses by the shortest paths. Alright, no bother. Just get rid of all this. Scale it all back. What's the only thing I care about now? I care that the opposite is what length? What length is the opposite? 60. What length do we want? We want the hypotenuse. That is sine, isn't it? we want sine x. What letter did he use? It was x, yeah. Sine x equals 60 over d.
Yes.
And then sine x is root 15 over 4. And then, the awkward one. Bring up the d and then divide it by, so bring up the d and then do 60 divided by root 15 over 4. And you should get your answer.
16 root
16?
15. Root 15.
16 root 15 and decimals?
61.97.
61.97. Is that the correct answer?
No, you're meant to get 140, I think.
Yeah, what? Alright, give me a look. 240.
Yeah.
Oh dear. We got cos alpha was a quarter, what they got. Alright, that's interesting. Right. I'll do a quick scan to see what may have went wrong. So, here's what I did wrong. See, alpha is 75.52. I got mixed up between alpha and x. This was 75.52. You get what I'm saying? But I haven't got angle x yet, do I? No. So I don't know what angle x is yet. Alright? So, what I need to do is I need to go back to my velocity of the woman here, and I need to input my values for cos alpha and sine alpha. So what I did accidentally was I put 75.52 as the angle she drifted upstream rather than the angle she attempted to go to the left and upwards, alright? So we're still in the game here. So phi w is 4 minus cos alpha, which we know is a quarter, isn't it? 4 minus a quarter I. And then sine alpha is root 15 over 4j. Okay. So put all that in then, and what do we get? What's it? 15 over. Yeah. 15 over 4 plus. So what I'm claiming is that the woman does get pulled downstream, right? But what I'm claiming is that she gets pulled downstream at a rate of 15 over 4 to the right and root 15 over 4 upwards. To the right, upwards. I'm going to figure out what angle x is now. So I'm going to do tan inverse root 15 over 4. Oh wait, make sure that root sign doesn't follow. Divided by 15 over 4. Uh, 14.47 or 14.48. And if I extend that onwards to where this is, it takes 60 meters across the river, that's 14.48, and I'm looking for angle length d. What I'm going to say is that d here, hoping this comes out as 240-ish. So sine 14.48 equals 60 over d. D equals 60 divided by sine 14.48. Huh? So what did I not do?
Sine 14.48 is a quarter.
Is a quarter.
Yeah.
Oh! Oh, it's a quarter, is it?
Yeah.
Oh, right. So what did I do wrong there then? Oh, divide. Oh, for God's sake. divided by sine 14.48. 240. Thank God. There we go. Is that alright? So it does work. Did anybody use the method? It's difficult, and you guys already had differentiation by the time we came along, so we settled on the derivative method that we used there. But here's what actually you can do. Alright? So I'm actually going to use my triangle law. Alright? So here's what we're dealing with. Alright. Everybody agreed that you're actually getting thrown downstream. VP. Everybody cool with that? Everybody happy that that's VPA? I'm sorry, not VPA. So not VP. What is it? A woman, is it? Sorry. Velocity of the woman, she gets thrown downstream. Everybody agreed? Velocity of the woman in water, she actually aims to the left. The velocity of the river drags her downstream. The velocity of the woman is the velocity of the woman in the river plus the velocity of the river. You okay with that? Now, here's what happens next. Okay, we do velocity of the river as well. For velocity of the woman, 1. Would everybody agree? I want the angle x to be as large as humanly possible. Is that alright? Make up 2 angles of your choosing, any 2 letters you want, opposite the information in the triangle. So what is it? Angle A and angle B. When you do magnitude direction, you'll find you only have 3 pieces of information. You do not have 4 pieces of information. And when you do the sine rule, you'll end up with this. 4 over sine A equals 1 over... Now, there is a rule to this. You set one of the angles to 90 degrees. But how do you know which one you make into 90 degrees? Well, one of them doesn't work and the other one does. If I set B to 90 degrees, what happens? What happens if I set B to 90 degrees? What'll happen there? Huh? It'd be 4 equals sine A. Can you sine inverse 4? Doesn't exist. That angle cannot exist. Try it. Sine inverse 4 in degree mode doesn't work. Alright? Go back a step. B doesn't work, so what should I go for instead? A. This is basically, there is a trick there. We all know that A is the largest side in the triangle, don't we? A has to be the largest length in the triangle. So stay here with me, lads. A has to be the largest length in the triangle because you're fighting the river. If you fight the river, it means your speed is going to be slower than the river itself. Okay? So here's what I'm saying. Alright? We set A equals to 90 degrees. 90 degrees is the smallest dominant angle you can possibly have. By A being as small as possible, this will make X as large as possible. Okay? And therefore, here's what happens. 4 sine 90 equals 1 over sine B. Sine B equals a quarter. And what's sine inverse a quarter? Really quickly. Was it? Alright, so 14.48. Alright? And actually, B and A are actually the same. Sorry, B and X are actually the same angle. Why are they the same angle? Exactly. And now all of a sudden, you have your 60 going across, your 14.48 going here, and we actually have the same thing we had last time, didn't we? And we can find out what D is really quickly. Alright. That's both.